Okay guys, let's proceed with the last example. Sorry because I make this one into 3 video because I want to reduce the time for each video. Okay, so I'm going to show to you the last example which involves a quadratic function, because as you can see from example A, B and C, you don't have anything with a quadratic function yet. Okay, so let's consider this function. If let's say your fs is equals to if your fs is equals to 3s plus 1 over s squared plus 1. So this is a linear factor, and the last one, this one is s squared plus 1, so this is a quadratic function. So as you can see, this quadratic function you cannot factorize. Okay, if you're using the calculator here, your s squared is equals to 1, your a is equals to 1, your b is equals to 0, and your c is equals to 1. So as you can see here, you end up with the complex root. Okay, so that you know this one cannot be factorized. So if you cannot factorize the function, remember you have to use the third one, which is a quadratic factor. Okay, because you cannot factorize the quadratic function or the denominator. Okay, so for this one you will have 3s plus 1 over s squared plus 1 is equals to, so the first partial fraction will be a over s. Okay, and the second one will be bs plus c over s squared plus 1. Okay, why bs plus c? Because this is a quadratic function. Okay, so the next step is for you to get the value of a, b and c. So 3s plus 1 is equals to a. So when you compare this one with the left hand side here, the missing term is s squared plus 1. Okay, plus, so the second one bs plus c. So you already have s squared plus 1. So you are missing, the term that is missing is variable s. So that's why you need to multiply by s. Okay, so expand this one will give you as squared plus a plus bs squared plus cs. Okay, so next factorize according to the variable. So the first one is s squared, so you will have a plus b s squared. So for variable s, you just have one, which is cs, and the last one is a constant a. Okay, so form 3 equation. So the first one is by comparing the coefficient of s squared. So on your left hand side you have a plus b. So on your on your right hand side you have a plus b, but on your left hand side you don't have anything with s squared, so this one will be equals to 0. So the second equation, c is equals to 3. And the third one involves a constant, a is equals to 1. So for this case, you don't have to use calculator because you can get directly the answer. Okay, so you already have your a, so you know that your b is equals to -1. Okay, so substitute into here will give you, okay, be careful. Before this, we are dealing with a linear factor, but here you have bs plus c. Okay, so just substitute first whatever value that you get into here, then only you factorize the constant. Okay, because you have, this one is not the same as the previous example. Okay, so therefore your ft is equals to, so what is your a? So a is equals to 1, so you just have to find the inverse of 1 over s, plus, so as you can see here, you need to find the inverse of your b is equals to -1, so you will have negative s, plus your c is equals to 3 over s squared plus 1. So as you can see, for this one you can get directly from the table, but not this one. Okay, so you need to apply properties. So the first properties that you can use is linearity properties, because you have a plus sign here, so you can split the function into 2. Okay, so therefore you have inverse of 1 over s, so negative, so you can factorize. So what is the first function? The inverse of s over s squared plus 1. Okay, plus, so what is the constant here? 3. So factorize 3, so you left with the inverse of 1 over s squared plus 1. Okay, so as you can see, this one you can get directly from the table, this one also. So for this case, your a squared is equals to 1, so your a is equals to 1. So this one here, your a squared is equals to 1, so your a is equals to 1. So this one, you know, this one will be going, this one will become cos function, this is sine function. Remember, when we're dealing with sine function, it should be a over s squared plus a squared. So since your a is equals to 1 and this one is already 1, so you don't need to multiply or divide by a constant. Okay, if you don't understand, please go back to my previous video and watch it again. Okay, so therefore your ft is equals to 1 over s is the inverse of 1 over s is equals to 1. Okay, minus cos t plus sin t. So this is the final answer. Okay, so we are done with the properties of inverse Laplace transform. Okay, so sorry, this one should be, sorry, this is 3, so it should be 3 sin t. Okay, I'm sorry. So the final answer will be 1 minus cos t plus 3 sin t. Okay, so we are done with the properties of inverse Laplace transform. So in my next video, we will take a look on how to solve first order and second order linear differential equation by using Laplace transform. Okay, so try to go back this example, and if you have any problem, please WhatsApp me or get to me either in a Edmodo or WhatsApp me if you have any problem. Okay, so I shall see you in my next video. Thank you guys. Assalamualaikum.